Here's pre-calc. It's problem 10-44. It is the derivation of the equation of a hyperbola. So it wants you to write an expression for the difference of the distances from your point P to each of the points that were centers in your circle. These are the foci. So basically, if you make a point on your hyperbola and you connect the point to each of the foci, which are these ones with the C, the difference, like if you take the longer distance minus the shorter distance, it's going to always equal the same number. So even if I take another point like this one, this longer distance minus this shorter distance equals a certain number. And it turns out that the number that it equals is 2 times A. Because if I move this point down, 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 all the way down to there, then I would have this distance, this, I don't know if you can tell it's blue, minus, well, I want to make this one yellow, this distance. But since this little yellow distance is the same as this blue distance right here, it's really just 2 times A. And why is it 2 times A? Because this is A comma 0. The distance from the middle to the edge is A. And so since there's an A there and another A there, so basically you're going to start this thing out with the distance, this longer distance, minus this shorter distance equals 2 times A. So that's what I'm going to do right here. I'm going to use the distance formula. There we go. So the distance formula is x2 minus x1. So this can be x2 and this can be x1. So it's x minus negative c. So that's why I have a x plus c here. And then it's y2 minus y1. Well, y2 is here, and y1 is 0, so that's just y squared. And then that gives me the whole distance of this longer distance. And then if I subtract the shorter distance, it's equal to 2a. The shorter distance is square root of x2, which is this x, minus x1, which is c, so it's x minus c squared, plus y2 minus y1, which gives me the y squared, and all that's equal to 2a because that's the constant difference. And so then we're just going to do algebra the whole rest of the time. So what you need to do first is you get one of the radicals on one side of the equation all by itself so that you can square both sides. When I square this, the radical falls off, or it gets eliminated. And then when I square this, I'm squaring a binomial, so I take the first thing squared, and then I take the first thing times the second thing times 2, that's what this is, and then I take the second thing squared. Well, this second thing squared, it actually gets rid of this square root when I square this second thing. So I'm just left with what's underneath. And then before I move to the next step, I just take a look at it and I ask myself, is there anything I can do to make this easier for myself? Well, I saw that I had a y squared here and a y squared here, so I just crossed them off. Okay, and then, so then what happened? Then I decided I did two things at once. I took this and squared it out. So this would be x squared plus 2 times x times c plus c squared. That's where that came from. And then this one became x squared times 2 times x times negative c plus c squared. Okay, but then I I noticed that I had c squareds on both sides, so I got rid of them, and I had x squareds on both sides, so I got rid of those. And I noticed that I had negative 2xc over here and a positive 2xc over here, so I added that to both sides. And then, so then I end just this over here, and then I've got the 4a squared plus 4a. I've got all this. So I need to get this radical by itself as much as I can before I square both sides. So I think I subtracted the 4a squared on this side. And then I notice I have a 4 and a 4 and a 4. So I just divided out that 4 because I don't really want to square that because then I'm going to have 16s and it's going to be messier. So I showed that I divided it out. Okay, and then what is this? So this canceled out and gave me x times c, and this canceled out and gave me the a squared, and then I think I'm just showing that I squared both sides again. And so when I square this whole thing, the a is going to get squared, and this radical is going to come off. But when the radical comes, it's still multiplying by the a squared, so that's why I gave these extra little. And when I square this whole thing out, it's the first thing squared times the first thing times the second thing, or plus the first thing times the second thing times 2, and then it's the second thing squared. And then over here, I end up squaring this one out. Let's see. Oh, yeah. Okay, so this side just all stayed the same. But over here, I actually did my a squared to everything. After I squared this out, because this is x squared, and then this times 2, and then this one squared. Okay, and then I distribute the a squared thing inside. But when I did that, so all that happened here is everything got an a squared. But then I looked at both sides of the equal sign and I said, hallelujah, because I had these were like terms. I just got rid of them. The a to the fourth didn't go anywhere, but I ended up moving it to the other side. So basically this one and this one canceled out. And then the rest of them I moved around. So I know that I'm supposed to have all the x's on the left. So this one's going to go on the left. This one's going to go on the right, if that makes any sense. That whole thing's all gone. That thing needs to stay there, and that thing needs to go over here. So basically, you'll see I moved everything around. I left this one here. This one came from over here. I moved it over. This one here came from that. And then this one was already here, and then I subtracted the a to the fourth. Basically, I moved things around so that only x's and y's were on the left, and all the other things were on the right. And then I remembered that I'm supposed to factor, so I factored out an a squared here. I factored out the a squared. And then they told me that I'm supposed to, oh, and I factored over here too. These two, and I just remembered that I was supposed to factor because that's what they had us do with the ellipse. So this left-hand side, these two terms, so I factored out an x, and then this other term had a y squared. And then I divide both sides by a squared times c squared minus a squared. See, I'm dividing both sides so I can get a 1 over here. And my a squareds canceled out, and my c squared minus a squareds canceled out, and I ended up with x squared over a squared and y squared over c squared minus a squared equals 1. And that's right here. And then it told me to write a little relationship between A, B, and C. And if you look at A, B, and C, do I have a better picture? This is A. From here, see that dark, dark, dark line? That's A. And then this height right here is B. But that's the same height as this height over here too, isn't it? That's B. And then what is C? Well, C is the distance from the center to the focus. So we so this is A and this is B, and this ends up being C. So A squared plus B squared equals C squared. I think I have a nicer picture of that on my lecture video that explains better plus B squared is C squared, because I don't think I did a good job explaining why this would be C right here. But anyways, so A squared plus B squared is C squared though. And so if A squared plus B squared equals C squared, then C squared minus A squared equals B squared. So I can just plug a B squared in and I'm done.